Hello sir, my name is Abhijit Gop and my topic is asymptotic analysis of complexity bound. Asymptotic notation is a way to describe the running time or space complexity of an algorithm based on an input size. It is commonly used in complexity analysis to describe how an algorithm performs as the size of the input grows. The three most commonly used notations are big omega, omega and theta. Omega notation. Omega notation represents the lower bound of the running time of an algorithm, thus it provides the best case complexity of an algorithm. The execution time serves as a lower bound of an algorithm's times complexity. It is defined as the condition that allows an algorithm to complete statement execution in the shortest amount of time. As we can see, there is a diagram of omega notation where g and b be the function from the set of natural numbers to itself. The function f is said to be omega if there is a contact c greater than 0 and natural number n0 such that then the equation will be this. Mathematical representation of omega notation. Omega g of n equals to f of n. There exist positive constants c and n0 such that 0 less than equals to cg of n less than equals to f of n for all n greater than equals to n0. Let us consider the same insertion sort example here. The time complexity of insertion sort can be written as omega, but it is not very useful information about insertion sort, as you can generally interested in worst case and sometimes in average case. We can see there are some examples. Next, theta notation. Theta notation encloses the function from above and below, since it represents the upper and the lower bound of the running time of an algorithm. It is used for analyzing the average case complexity of an algorithm. For average case, theta add the running times for each possible input combination and take the average in the average case. As we can see, there is a diagram, and as the diagram follows, let g and f the function from the set of natural numbers to itself. The function f is said to be theta if there are constants c1, c2 greater than 0 and natural numbers n0 such that c1 into g of n less than equals to fn less than equals to c2 into g of n for all n greater than equals to n0. The above expression can be described as if f of n is theta of g of n. Then the value of f of n is always between c1 into g of n and c2 into g of n. For large value of n where n greater than equals to n0, the definition of theta also requires that f of n must be non-negative for values of n greater than n0. The execution time serves as both a lower and upper bound of an algorithm's time complexity. It exists as both most and least boundaries for a given input value. Mathematical representation of theta notation. Theta g of n equals to f of n. There exist positive constants c1, c2 and n0 such that 0 less than equals to c1 into g of n less than equals to f of n less than equals to c2 into g of n for all n greater than equals to n0. Here theta is a set, and here some examples as you can see, and here is theta provides next bounds. Next, big O notation. Big O notation represents the upper bound of the running time of an algorithm, therefore it gives the worst case complexity of an algorithm. It is the most widely used notation of asymptotic analysis. It specifies the upper bound of a function, the maximum time required by an algorithm, or the worst case time complexity. It returns the highest possible output value for a given input. Big O in worst case, it is defined as the condition that allows an algorithm to complete statement execution in the longest amount of time possible. In the diagram here, if f of n describes the running time of an algorithm, f of n is big O if there exists a positive constant c and n0 such that 0 less than equals to f of n less than equals to c of n for all n greater than equals to n0. It returns the highest possible output value for a given input. The execution time serves as an upper bound of an algorithm's times complexity. Mathematical representation of big O notation. Big O g of n equals to f of n. There exist positive constants c and n0 such that 0 less than equals to f of n less than equals to cg of n for all n greater than equals to n0. For example, we can consider the case of insertion sort. It takes linear time in the best case and quadratic time in the worst case. We can safely say that the time complexity of the insertion sort is big O n square, where big O n square also covers linear time. If we use theta notation to represent the time complexity of insertion sort, we have to use two statements for best and worst case. The worst case time complexity of insertion sort is theta n square. The best case time complexity of insertion sort is theta n. The big O notation is useful when we only have an upper bound of the time complexity of an algorithm. Many times we easily find an upper bound by simply looking at the algorithm. Here you can see some examples. Here U represents union. We can write it in this manner because big O provides exact or upper bounds. Thank you.